Welcome, everybody, to the Logos Dev Club. Welcome to the Logos YouTube channel. Welcome to the Logos X account and live stream, wherever you are watching, whether it is X or YouTube. Please immediately, with great haste, like and subscribe and share. Click the retweet button, quote tweet, all of it immediately. Please and thank you. I am Chair. I'm here to prop you up. I am the program manager at Waku. Waku is the peer-to-peer messaging protocol that is part of the Logos core technology stack. I am joined by SP, Waku research engineer. Hello.
Hello.
Thank you for joining today. You
My
will
pleasure.
be vibe coding with Waku. Can you take us through what it is you will be building today?
Yes. So vibe coding a prototype of a new way to synchronize messages on Waku. I guess that would be the goal. Um, it's a bit technical. We're gonna do a private set intersection between two. Well, I guess set obviously. But in the context of Waku, that would be two Waku nodes that want to exchange messages without revealing their interest.
Their interest,
Yes,
meaning what topics they're interested in
yes.
subscribing to.
Their topic of interest. They don't want to reveal that, but they still want to sync messages on those topics.
All right. Well,
Yeah.
the wheel is yours. I will be asking questions from time to time for my own clarity, mostly. If
Yes,
you are
you
in the
ask questions.
audience, I will. It's almost guaranteed. If you are in the audience and you have a question, we can see the chat wherever you are watching. If you have something to say, please say it. We can see it. If it's a useful question, we will acknowledge it. All right,
Yeah.
the car is yours, SP.
Yeah, so this is vibe coding. It seems doable, but it's 100% like improv. So we're gonna try to make it work, but no promises. Um,
I'm confident.
yeah, so add a chat with in this case it's Grok, and seems like we're gonna use the Dalek crate. We're gonna code in Rust. That's also important to mention. We're gonna use a crate called Curve 25519 Dalek to handle the cryptography. And it seems like it contains everything we're gonna need to do the private set intersection. Um, yeah, so already pre-generated like all of this text. I'm not gonna read to everything, but there's pretty much the dependency we're gonna need and some code below, and it kind of explain how it works. Um, so I think we're just gonna start by just copy pasting. Like a good vibe coding session is always gonna be copy paste, right?
For my own curiosity, if you could go over the prompt like very quickly and a super high level, what the prompt is that produced this.
Um, the prompt. Well, there's a lot of prompting. It was just
Okay.
me like brainstorming with the AI basically, and then the last prompt was just uh, asking if I was to use that uh, library, what would the protocol looks like? So
Okay.
basically, Grok just answered, if you use that library, you would do all of this, and then it would work this way, and blah blah blah.
Perfect.
But yeah, I did ask a lot of questions just to see if it was possible, and it seems like it is possible. there's many different ways to do it, some more complex than others. I guess the first prompt was, yeah, I'm looking for a Rust crate that can do private set intersection. So the answer was
Straightforward.
there's none. So you have to build it yourself, which is kind of what we're gonna try to do. Um,
That's
yeah.
perfect context.
All right. So I'm gonna copy the dependency that the AI tells us we need. Um, we're just gonna paste it here. So obviously we need the cryptography library. Oh, hash function. Rand is everything is to do with number generator. We're probably going to need more than just that, but for now, should work. And then yeah, maybe I could go through the protocol steps. Basically, we have two actors. We have Alice and Bob. They want to find the intersection of their set, but they don't want to reveal the set of topics that they have to each other. They just want to know the intersection so they can synchronize it. So I guess the first step is to agree on the cryptographic library you're going to use, which is going to give you the curve. So that's what it's explained here. What we're going to do is hash topics. The hash is going to be used with this function. So it's a ristretto point from a hash. So, and then once we have this point, we're going to be able to multiply it and basically do a blinding. I should also say I'm not a cryptographer, so I don't know exactly how the math work. I can't explain to you, but I guess that's why we have AI. Okay, next step would be blind the points. So we have the ashes that now are points. Each actor is going to blind their own points, which is just a multiplication. So Alice and Bob, they both do this, and then they exchange their blinded point, right? And the blinding obscure the topic. So even if Alice sends the entire list of blinded point to Bob, Bob cannot get the topics from the blinded points. And then you compute again. So you take, so Alice is going to take Bob's point. You're going to blind them again. And Bob is going to do the same. And the points that are equal then are the intersection. Yeah, that's that's how it works.
Is this calculus? Are we doing calculus now?
Yeah, we're back in school.
Yeah, that's I couldn't make it past trigonometry, but I'm glad we're here. I'm doing it. All right. No, don't let me interrupt you.
So we're gonna have two sets of double blinded points. We're just gonna find the intersection on those two sets, and then we're gonna like each party knows the topic that corresponds to the double-blinded points, and so they both can now know the intersection. And then they didn't in all the protocol, they didn't reveal any other information than the intersection. So I guess the last step is to, I guess, reveal the intersection and do this synchronize the message on the this intersection of topics. Maybe we're not gonna get to that today, but we have Waku Sync, so it's not it would not be difficult to adapt Waku Sync to work with this private set intersection prototype that we're gonna build. And now I guess the AI gave us some pseudocode, which we're just gonna copy paste because that's always gonna be the starting point. So we're just gonna do that. There you go. Not gonna need that. Okay.
Folks, if you have questions in the chat, especially if you took any advanced calculus in school, please, we want to hear from you. If you're watching on Twitter, like and retweet immediately. YouTube, subscribe, like. Thank you.
Okay, so we have the step again, except in code this time. We have the function, ECDH, the private set intersection. We start with Alice ashes, and then we have Bob ashes, and it gives us a result, which is it's going to be the intersection. So maybe we could start by creating a function that's going to give us some random topics. Maybe we do random topic. I mean, they're going to be topic ashes. So random topic ash. It's going to return 1 ash. So they're all 32 bytes. So 32 bytes. And to do that, we need, I guess, randomness somehow. So RNG. Anything that implements, I guess it's going to be OSRNG, probably. Or maybe we need to just ash a topic. That's a good question. Maybe random. Maybe random is going to be too difficult because I want to also create a test, right? So what would be the test that would make sure that what the AI come up with is actually working? I think that would be the kind of the first thing we work towards, because I don't know if all that code is gonna actually do the thing it's supposed to do. So maybe this function is gonna be in the test module. So we're gonna start with trying to build a test that would tell us if it works.
Hold on, are you using test-driven development and writing actual code?
Yes.
Holy moly. What even is that?
Yeah. Crazy, I know. Okay, so how do we define that it works? We need to know the intersection. It needs to do a set intersection, that's for sure. So I guess, yes, to do check for set intersection. Okay, so we need to check for that. That's for sure. What else do we need to check for to make sure that it actually works? We need to check that, I guess, nothing else is revealed. Nothing else is revealed. Because otherwise it's not private. And we're doing private set intersection. Yes. So check the... Okay, so check for the set intersection. If it's actually a set intersection, check that nothing else is revealed. Now we need to start somewhere. We need to start with two sets. So create two sets. And then I guess create common elements, right? So we're gonna have two sets. Then we're gonna create some common elements. Then we're gonna do the thing. So do the thing. And then we're gonna check the set intersection and then check that nothing else is revealed. Basically, I'm not sure. Yeah, I guess the size of the set intersection is probably what we're gonna check here. Yeah. So maybe check. I can't type. Check intersection size. Probably that's going to be the step. This is easy. We have standard library as intersection, so we can check that. Do the thing. That's going to be the hard part. Create two set. That's also easy. All right. So create two sets. We need to create two sets. To do that, we need this. We need to create elements. So let's start with we're just going to try to fill an array. So let's so an array, it's mutable, and it's going to be, well, this. Then RNG. Don't remember exactly what's the how do you call that exactly? Is it fill? I think it's fill. Wait. Oh, I know why it's not working. Okay. Extension. Nim, not going to be useful. Nim, no. Yeah, because we need Rust stuff, so that's why. Without tools, it's always more complicated. Okay, we don't need that. We don't need that. Docker, that's fine. We can use that.
That's foreshadowing for Nim Club coming to a live stream.
Yes, because we like Rust, but we also like Nim.
Oh, Rust is on the roadmap.
Okay, so now I can do. Can I do this? Wait, what's the command again? Or this maybe? Aha. Now we have. It's fill bytes. Aha. Okay, so fill bytes, and then you do is it this?
It would be amazing if you could pass Alice in there, kilobytes Alice, but it's not the case.
So OSRNG that fill bytes the key, and then it should fill it, probably. Yes. Okay. I'm a bit rusty in Rust, which is ironic. We use Nim a lot. Oh, OSRNG is a strut. Interesting. Okay. So you don't need that. Is it U8? Wait, in Rust it's U8? I think it is. Wait, what does it say? You need to use Rancor. Okay, use Rand. Wait, is it random? Rancor. Rand. RNG core. Right? Is that what they're saying? Okay, so expected value. Okay, so I guess it's going to be 0. Yeah. Okay. So you create an array, fill it with 0, then you call the RNG. Oh, it needs to be immutable. I guess it's a reference as well. Okay. Yeah, it's working. Okay. So we can create random topic hashes. I mean, it's basically 32 random bytes. It's not really a topic, but with that, we can create 2 sets. So set 1, or let's do Alice set. And it's going to be what? Evec. Maybe it's actually a set hash set with capacity. Let's say it's going to be 100. All right. So Alice set. Now we're going to do Bob set. It's the same thing. Bob set. Okay, so we created 2 sets. They're empty, but we're going to fill them by calling this. Yes. I'm sure there's a clever way to do it in a functional way, but I don't remember. I think it's map, something like map. Yeah, like I said, I'm rusty in Rust, which is. Let's just do the imperative way, I guess. And then I only remember the Nim way to do this. We're in trouble. So it's
not the worst thing in the world.
I mean, the syntax is similar. It's yeah. Maybe the tools is gonna tell us what's wrong. I think it's something like yes. Okay. So in Rust you can just say okay. Yes. Okay. We're not gonna need I anyway, but It's going to be what? Insert? Yes, insert a value of the value this. We need the RNG. Oh yeah, we need to make the RNG. So let init RNG equal OS RNG. I'm not sure how to initialize this. I don't remember. Maybe just this. Is that enough? In Rust, you always need this. Oh yeah, semicolon. Because in Rust, there's always a semicolon. But in Nim, there's never a semicolon. Yes, and now it's working. So great. I guess we're going to do the same thing for Bob. It's not pretty code, but it's going to work still. Yeah, so insert. So each set now would have 100 elements, but maybe we need, let's say we're going to have 10 common elements. So we're going to do 90 different elements, and then we need to create a common element. So our to-do, create common elements. I guess it's going to be a loop. It's the same thing, basically, except it's going to be 10. And we create one value, and we insert it on both sets, right? Does that make sense? Yes, makes sense.
It's perfectly clear.
Usually you would randomize everything, but yeah. All right, I guess we're ready to do the thing. But before that, before the important we're going to check for set intersection. So how we're going to do that? We need to... So since it's a test, we know that the sets before they're blinded, right? So I'm thinking that we just do the set intersection now and then carry it on after the private set intersection to see if the both intersections are the same. That would be the simplest thing to do. Yes. So I'm not sure, Alice, Bob. Is this the... I guess it's not this. So intersection, and it's gonna be Bob. Yes. Okay, Bob set. It's a reference, obviously. Okay, so we have the intersection here, and then later we can check that everything matches after we do the set intersection, but the private version of it. So we do just a straight up intersection here, then we're going to do the private one, and then we're going to check both. So it's going to be basically this. So something like assert equal, let's call this public intersection, and we're going to have private intersection. Oh wait. can't type here. Private. Yes. Okay. So this. So later we're gonna do this. That's gonna prove that the two intersections are the same. I think it's gonna be a bit more complicated than just calling this, but for now it's okay. Check that nothing else is revealed. Yeah, I guess the size. I mean, this check is also going to check the size, so yeah, we're just going to leave it at that for now. Okay. Yes. So we're going to work on doing the thing, which is the most interesting part. So we are going to go back up, and this function is the one that's going to do the private set intersection. Yes. So inputs are Alice ashes and Bob ashes. We have ash sets and not vec, but we can just change the type. It's not that bad. Okay, so let's see what the AI came up with. We initialize the randomness here, but actually we don't need to do that. We're just gonna pass it. So RNG, it's gonna be this, and it's gonna be OS RNG. So now we don't. Wait. Huh? What does it say? Cannot borrow. What? It's just mutable? No. Okay, now I'm confused. Wait, what did I do here? Yeah. So RNG, then mute. So it should be this. Okay, so this is implied. Yes, okay. So our function, we're going to pass the RNG module we want. The step one is going to be generate secret scalar. So Alice secret and Bob secret. All right. Those secrets, are they supposed to be secret keys? Or maybe every let's see what the AI says. Okay, so setup. Both parties implicitly agree on curve 25519. Build it into the crate. Yes. E generate a random secret scalar. But why? Why? Does it explain why? Oh, it's for the blinding. Yeah, okay. So A is the number you're going to multiply with all the ashes. Yes, okay. That makes sense. So Alice has a set of ashes of topics and a secret number. Alice is going to compute the multiplication between this secret number and all the ashes in the set. And that's Alice blinded points. And Bob is going to do the same thing. Okay, that makes sense. Where's the vibe in this coding? Yeah, I'm not sure what vibe coding is. It's kind of half organic coding now and half robot enhanced, I guess. So yes, so Grok added this. That's the first step. So that makes sense. I'm not sure where Scalar comes from. It comes from the cryptographic library. Okay, so we're good. That should work. So we have Alice secret, Bob secret. Step 2. All our points needs to change type to a restricted points. Okay, so we're gonna have all the points. So Alice ashes, blah blah blah. Then H. H is wait. Okay, so Alice is ashes. Yes, we iterate through all of them, and each of one of them we do this. Wait, do we ash them again? Seems like it. So this function ash a slice of bytes into a ristretto point. Okay, so it's oh, I guess we don't need to do that. We don't need to ash it again. It's already a ash. But is there another function that doesn't ash anything?
I went to a hash function once in San Francisco.
Really? What happened?
It's good vibes.
Okay. So I guess we don't need. So if this function ashes Alice's elements, we don't need to ash them beforehand. Okay. So maybe we need to create topics and not ashes of topics. I mean, for this example or this prototype, I guess that's fine. We're gonna ash twice, whatever. We're vibing here, so double ashing is fine. Yes. So this is the function. We're gonna call it here because to do the thing, we call the function, and then we pass RNG, and then we have to pass Alice set into. Need to change it to a vec. We could triple ash it, but I mean, we don't need to. Is there no into vec? Pretty sure that exists. That's a function that exists. Into vec. No. Okay, so Bob set into vec into vec. And then private intersection. All right. Okay, so RNG, yep, we need, it's a mutable borrow. It's a mutable borrow, and into vec doesn't exist? Or we just say into? Maybe? No? I'm sad. I really want a into Vec. Pretty sure there's something to do here, but into. So maybe we're not going to use Ash set, but Vec. Vec. That's going to be easier. Vec. It's not going to be insert. It's going to be add. Or is it add? No, it is not add. It is append. Ooh, interesting. Okay, append. Is it append? Append, move all the elements of other into self, leaving other empty. Oh, it's not append. Okay. Well, is it add? Insert? Oh, it is insert. Okay. So vec. Oh, but it needs an index. Okay, yeah. I. There you go. Easy. I know how to code, believe it or not.
Vaslav says the more you hash, the more vibe there is. I can't agree more. Vaslav commenting from X. If you are watching on X or YouTube, please leave a question in the chat. If you have any, please share the stream. Thank you.
All right, so our sets are now vectors of elements, but now we can't do intersection. But we can do the private intersection, but not the public one. Okay, so we need, well, they're not sets. Vec. Okay, so we need to create the actual sets. So Ash set. I'm pretty sure you can do Ash set from Alice Vec. Pretty sure that should work. And then we do the same thing for Bob. No, it does not work. Maybe it's from iteration. Yeah. Yes, that's working now. Great. All right. We can't compare it here, but those two things are working. Okay, good. Let's go back to the private set intersection. Okay, so secrets. We ash again. We get ristretto points for Alice and Bob. Then we do the blinding. So every point, so Alice points, iteration, we map every point and we multiply with the Alice secret. And then we collect all of those. All right, that makes sense. That works. We do the same for Bob. And now step 4, exchange blinded points. Simulated, use network in practice. Yeah. Thank you, AI. Yeah, we're going to use network in practice, of course. We're going to use Waku. Okay, so we can...
It's just a mixture.
Yes. What were you gonna say?
No, I said it's just making sure.
Yeah, of course, Waku. So,
Let me ask you a
yeah.
question. I'm sure maybe others are probably thinking the same thing. Just for my own clarity, I'll describe what I think is happening, and then you can correct me. Two users are trying to create a secret hashed topic that only they both know. They used some encryption method to, well, one hash is their own, the other hash is their own, and they are trying to find the intersection of their two elliptic or curves, let's say, and that becomes the topic, whatever that intersection point is, and that's calculated, and that becomes the content topic. Am I close?
Um,
Not really.
no.
Okay.
Okay,
I'm glad I
let me
asked.
let me try to explain it better. So Alice is blinding every single hash of their her topic. So every topic is a number,
Mm-hmm.
and Alice has a secret number. All of the number corresponding to the topic, she multiplies with that secret. So the result is a new number, and you can't get the topic from that, right? You can't even get the
The
hash
uh-huh.
because it's been multiplied, and we don't know by what. Bob does the same thing, and then they exchange all those numbers. And
Mm-hmm.
then Alice, which is step 5, it's the double blinding. So she takes Bob blinded numbers and she multiplies that with her secrets.
Interesting. Uh-huh.
And then Bob does the opposite. Bob's takes Alice blinded numbers and multiply it with Bob's secret.
Mm-hmm. Mm-hmm. I'm following.
And then when you do that, if the elements are in common, they're going to result in the same number on both sides, on both on
Uh-huh.
Alice and Bob's side.
Because they're
All the
multiplying essentially the same numbers, just
yes,
in whatever. Okay, cool.
I guess would it be because is it because of the commutative property of multiplication? I
Oh,
don't
I
know.
don't know.
I'm
I'm
not
just
good.
hold on. I'm filling in my gaps with.
I'm not good enough at math to explain why it works, but yeah, it gives the same number, so you can know if the elements are the same on both sides.
And then that verifies each other's quote unquote identity to each other, and they can.
Not identity. It just gives you the
The topic.
the set intersection.
Okay. I'm
But
closer to understanding now.
both Alice and Bob, they knows the double blinded number that are the same, and they know which topic correspond to those. Each individually, they know that, but during the exchange, they never exchanged that information. So if the number is not the same, they will not reveal that topic because they know the other person does not have that topic. That's why the set intersection is private.
Okay. I
Take
I I
notes. There's going to be a quiz at the end.
I thank God this is being recorded. No, I appreciate it. I think I'm closer. I'm closer.
All right. So step 5, compute the double blind. So set of blinded numbers are exchanged and then blinded again with each other secrets. Let's check the code, see if that's actually what's happening. So Alice double blinded. It's a vector of hashes. It starts with iterating Bob's blinded numbers, and then multiply those numbers by Alice's secrets. Yes, okay. Then it calls compressed to bytes. What's this? Compress this point using the Ristretto encoding. Okay, so I guess that's just part of the cryptographic library. I'm not sure why you need to do that, but I guess we're gonna trust the AI knows better than us. So compress. So okay, so ristretto point, that's the type. Compress gives you a compressed ristretto, and then to byte, it gives you a byte array. I'm guessing the byte array is 32 bytes, because otherwise it can't work. Yeah, okay, so that makes sense. So Alice does this, Bob does the same thing. And now step 6, find the intersection by comparing compressed bytes. All right. So this is from the point of view of Bob. Or wait, Alice maybe? No, it's from the point of view of Alice. Wait, no, it's the point of view of Bob, because it's Bob double-blinded set. Okay. So you create a hash set with all the double-blinded points, and then you check for an intersection. I guess you can just do intersection. Yeah, why do that? Let Alice set. Whoops. Alice set. We're basically going to do the same thing for Alice. Right. So the AI here seems to do the set intersection manually, which is, I mean, we don't need to do that. So we can do it with I think the standard library as the intersection function. Yeah, so you don't need to do any of that. Yeah, so let private intersection equal Bob set that intersection and Alice set, and there you go. And then you return private intersection. No, you can't return the private intersection because that's not the correct type. The type is a vector of hashes, but we could just say a hash set of yeah, that would work, right? Right? It should.
Sure, why not?
A hash set of wait, so the intersection function returns what? Oh, it returns a type called intersection. Okay, well, okay. So what can we do with this type? We can do, wait, intersection. No, I want the, that's the example. You can collect. Okay, so you would just do collect, right? Or into an iterator, and then you collect it, right? Right? No, you need to do it before. Okay. So this is a hash set of bytes, or not bytes, but hashes. And then you return this, right? Please? Maybe this? No? Okay. I need some documentation. I guess we can just check, right? The documentation. This, the Rust standard library. Okay, so intersection struct hash set intersection. What are the functions I can call? I can call I can call iterator on it. Okay, that's good. Iterator. Then I can call collect, probably. Yeah, I should be able to. The type. It's not the same type. That is why. Okay. Interesting. So when you do an intersection, it gives you a reference to the hashes and not the hashes themselves, which is interesting. What if I do this? No? You need to borrow it. So you borrow, but then yeah, that's what I want to do, basically. Can't I actually do that? Oops. Yeah, the type is not correct. It's a reference to a hash and not the hash itself. Yeah, that's annoying. Okay. Surely there's a... Oh, maybe collect into? No, that's a nightly. Hmm. I guess there's no way to do that. The easiest thing to do would be to just do this, and now it works, right? No, it doesn't work. Oh no, okay. Yeah, in Rust it's a bit complicated because when it gives you a reference of a local variable, you can't use it when you exit the function. So I guess I'm just gonna copy everything. I'm sure
So
there's
you just make everything one big function, right? I'm kidding. Don't let. No, I'm kidding. Pretend like
yeah,
I
we could
didn't.
do we
Pretend like,
could just do that.
pretend like I didn't even say it.
No, that's true. That's true. You could just do that. I'm trying to do it the proper way, but I guess yeah.
No. I've written exactly 0 lines of Rust in my life, so don't
Yeah,
follow my intuition.
yeah, it's been some time since I've been playing with sets in Rust, so I'm not sure exactly what would be the best way to. Um, hmm, because that's a yeah, okay. I think we're I think you had the correct yeah, we're just gonna
It's beginner's luck.
yeah, I don't want to fix this. That's just stupid. We're just gonna do the thing. So here, boom, there you go. It's gonna do the thing for sure. Oh, just gonna have to correct some things. Right. It's gonna be ls set, and then everything else is the same. So private intersection, that's the hash set, except it's a reference. And now, can we compare the public intersection with the private one? No, we can't, because actually we didn't. So the pairing between the topic and the double blinded value, we didn't do that. So we can't associate the topic with the double blinded value. So we can't compare the intersection. Uh-huh. Yeah, we can't. Huh, that's annoying. So we would need to keep a mapping between a secret mapping between the topics and the points as they are blended once and then twice, so that we can then check the private intersection and the public one. But since we didn't do that, then we can't. We just have uh, a double blinded intersection of points, which is not useful in itself. It's been more than an hour. Can we maybe do that another time, or should we
Absolutely.
continue?
I think we can save this point and continue on whenever is best next. That's
Yeah,
cool
I
with
think
me. All right, folks. Well, you were just treated to a bona fide, artisanal, legitimate, hand coded vibe coding session that leaned very little on LLMs. Can you imagine? Could you even conceive of this? I appreciate it, SP. Thank you very much. I look forward to the
thank
conclusion.
you.
And in between now and then, I will try to wrap my head around exactly what's going on. In fact, this is the main question I have left is backing all the way up to why. We're discovering the topics based on all of these the hashing and the calculations and triple hashing even. But am I correct in assuming that this is all to determine a content topic that will be used to communicate between these two parties?
Yes.
Okay, great. So that was my great big question. It's like why all these calculations? It's to determine a content topic. So when they are using the Waku network to broadcast and receive messages, that they know which content topic each other are interested in, and so we hash. We hash until we find the intersections.
We hash and then we multiply.
Cool.
So yeah, it would be in the context of Waku Sync, which is another protocol that Waku uses, which is it's not relay. It's not when you actually publish messages. It's when you want to. It's a it's a way to synchronize a set of messages between two nodes. So RLAN relay in Waku, that's the protocol that's gonna. It's basically a pub sub protocol, except protected by RLAN with our own Waku twist on it too. Um, but Waku Sync is used to really find the differences in the set of messages that two nodes have.
The two
But to
nodes.
do that, they
Mhm.
need to negotiate what topic they want to synchronize. But to do that privately, you need math and cryptography like this. Otherwise, you would have to send all your topic of interest to the other person. And the other person would have to do this with you, which is not private at all.
Right. Because that activity on the network is public. That's okay. So there can be
Not
the
even
actual
it's not even that public. The other node you're communicating with, you don't want to tell them
everything that
your topics that you're interested in because you don't know who that is.
Yeah.
You just want to sing some messages. So yeah, the less information you reveal, the better.
Perfect. Well, I look forward to the conclusion. It will be coming to you soon, folks. We are going to be here. We're calling the Logos YouTube and Logos X account home now for the Waku Vibe Code streams as part of the brand new, and you saw it first, Logos Dev Club. So thank you for being here. Please subscribe and turn notifications on so you don't miss anything. We will be back very, very soon for another Waku Vibe Code stream and a Logos Dev Club session. SP, once again, thank you very much, and I will see you very
Thank
soon.
you.
We'll see you soon, folks. Goodbye. As I search for the music, there it is. See you later.